Welcome to The Explainer. Today, we're going to put on our consultant hats and really master a super powerful statistical tool, analysis of variance, or as you'll hear me call it, ANOVA. We're not just going to skim the theory here. We're breaking it down into a practical framework that you can actually use to make those sharp, confident, data-driven decisions.
All right, here's our game plan for today. First, we're going to nail down the exact problem ANOVA solves. Then, we'll open up the toolkit and check out the different types. We'll do a deep dive into the most common form, one-way ANOVA, walk through a real-world example step by step, and finally, learn how to interpret the results and put this powerful tool to work.
You know, every grade tool is designed to solve a specific problem, right? So before we jump into the how of ANOVA, let's get super clear on the why. What's the fundamental question this thing was built to answer?
So, picture this. Your team is looking at 3 different marketing campaigns, maybe 4 potential suppliers, or 5 different manufacturing processes. A simple A/B test, what a statistician calls a t-test, just won't cut it. It's basically like trying to use a screwdriver when you really need a wrench. So what do you do when you need to compare the average results of 3 or more groups all at once?
And that, right there, is where ANOVA comes into play. While a t-test is your go-to for a simple, head-to-head comparison between 2 things, ANOVA is the statistical powerhouse you need for those complex, multi-group situations. It lets you test whether the average outcomes of 3, 4, or even more groups are truly different from one another, all in one single, elegant test.
Okay, so now that we know why we need it, let's open up the toolkit. See, just like a good consultant has a framework for every problem, a good analyst has different types of ANOVA for different scenarios. It's all about choosing the right tool for the job.
So you've basically got 3 main tools in the kit here. One-way ANOVA is for when you're analyzing a single factor, like comparing our different battery brands. Two-way ANOVA steps things up a notch, letting you analyze 2 factors at the same time, say the battery brand and the temperature it's operating at. And the whole with or without replicates thing, that just depends on whether you test each specific combo, like brand A at 50 degrees, multiple times or just once.
All right, to really get a feel for how this all works, we're going to do a deep dive on the absolute workhorse of the toolkit, the one-way ANOVA. Seriously, if you can understand this engine, you'll get the core principles behind all of it.
So what is it really? At its heart, one-way ANOVA, invented by the genius R.A. Fisher, is a method for testing a really simple but super important idea. Are the averages of all my groups basically the same, or is at least one of them the odd one out? And the kind of wild part is how it does it, by looking at the variance or the spread of the data.
Okay, a quick but really important point. For any of these tests to give you results you can trust, your data has to play by a few rules. The samples have to be representative, the data needs to be continuous and normally distributed, and crucially, the amount of variation within each group needs to be about the same. Just think of these as a pre-flight checklist you run before you do the analysis.
So, how does this whole variance analysis thing actually work? Well, it starts by splitting all the variation in your data into 2 big buckets. The first one is the sum of squares factor, which is just a fancy way of saying between group variation. Think of this as the signal. It's measuring how different the groups are from each other. A big SS factor suggests there are some real differences going on. And the second bucket? That's the sum of squares error, or the within-group variation. If the first part was the signal, this is the noise. It's just the natural random jiggle of data points inside each group. It's the background chatter that's always there. This calculation just puts a number to it.
And here's where it all comes together, the F-test statistic. This is the heart of ANOVA, and it's actually a beautifully simple ratio. It's the signal divided by the noise. The variation between your groups divided by the variation within them. So if you get a big F statistic, it means your signal is way louder than the noise, and the differences you're seeing are probably real.
And finally, we get to the p-value. This is the ultimate decision maker. It takes that F statistic and translates it into something we can all understand, a probability. It basically answers this question. Okay, let's pretend for a second there's no difference at all between these groups. What's the chance I'd get a result this crazy just by random luck? A tiny p-value means, yeah, not likely. So you can be confident there's a real difference.
Okay, that was a whole lot of theory, I know. But the best way to really get this stuff is to see it in action. So let's use a real-world example to see how all these pieces fit together to give us a clear business decision.
This is the exact 5-step process any good consultant would use. It's structured, it's logical, and it gets you from a question to a data-backed answer every time. You set up your hypotheses, you run the numbers, you find your F statistic, and you make the call. It's a rigorous process you can use again and again.
All right, here's our scenario. A car manufacturer needs to pick a battery supplier. They want to know if there's a real significant difference in the average lifetime of 3 of the top battery brands. This is a classic business problem, and it's absolutely perfect for ANOVA.
So the engineering team grabs 5 batteries from each of the 3 brands, that's 15 batteries in total, and runs them till they die under the exact same conditions. This table just gives us the quick summary of what they found, the number of batteries for each brand, and the total lifetime hours they got out of each group. Okay, so this sets up our 2 competing ideas, our hypotheses. The first is the null hypothesis. Think of this as the skeptic's view, or the default assumption, that nope, there's no difference at all, they're all the same. Then you have the alternative hypothesis, which is what we're really trying to find out, that actually, yeah, at least one of these brands is different from the others.
All right, so after all the calculations are done, after we've crunched the sum of squares and figured out our F statistic, we get to the moment of truth. It's time to interpret the results and make the final call. Is there a real difference or not?
The easiest way to make this call is with the p-value rule. In business, we almost always use a significance level of 0.05. It's just a standard cutoff. And the rule couldn't be simpler. If the p-value is low, the null must go. If it's less than or equal to 0.05, we say reject and conclude there is a statistically significant difference. Now, there's another way to get to the exact same conclusion, and that's by using the F statistic itself. You just compare the F statistic you calculated from your data with a critical value you look up in a standard table. If your number is bigger than the table's number, you reject the null hypothesis. It's just another way of saying your result was too extreme to be just random chance.
Okay, so we've covered the why, the what, and the how, but now we get to the most important question in any analysis. So what? Why does any of this matter? How do we turn this stat speak into actual value?
Look, here's the bottom line. ANOVA gives you a rock-solid, structured way to compare multiple options and know if the differences you're seeing are real. It takes you past gut feelings, past just eyeballing averages in a spreadsheet. It tells you if what you're seeing is a real signal or just random noise. It's the difference between guessing and knowing.
Think of this tool like a new pair of glasses for looking at your data. It can help you spot huge insights that are just hiding in plain sight. Are your marketing campaigns really performing differently? Do your suppliers actually deliver at different speeds? Is one of your factories truly more efficient? ANOVA lets you answer those questions with real confidence. So I'll leave you with this. What hidden differences in your data are you waiting to uncover?